Hey guys, so we are going to be doing the Unit 9 review. So pay attention, feel free to scroll ahead if you just want to check on the ones that you don't know how to do. Alright, so number 1, we are doing the area of our triangle. So area of a triangle is going to be 1/2 base times height. 12 is our base, 8 is our height. So we're going to get 1/2 12 times 8. And our area is going to come out to be 48. All right, number 2, since we have an angle and a side, we're going to have to use a little bit of trig. So 14 is going to be our opposite, and then we still need, that's also our height, we still need our base. So this side is going to be our base, it's going to be our x. So we're going to be using tangent since that is our adjacent side. So tangent of 40 is going to be our opposite 14 over our base. So then we're going to take our tangent of 40 and our base and we're going to switch them. So base is going to be 14 over tan of 40 and that comes out to be 16.68. Then our last step is to calculate our area. 1/2 16.68 times 14 and our area comes out to be 116.79. Alright, moving on to number 3. Number 3, again, we have an angle and we have this 15 right here. So we're going to have to use trig. So I'm going to find the length of this side down here. So we're going to be using cosine of 35 and it's going to be equal to our adjacent x over our hypotenuse of 15. So 15 times cosine of 35 is going to equal x and x comes out to be 12.29. After I got to this part, I just did the Pythagorean theorem. So I did 12.29 plus, I called this side y, so y squared equals 15 squared. So when you calculate, you're going to get y squared equals 74. So y is 8.6. Then from there, since it's just a rectangle, we're going to get our area is 8.6 times 12.29. And our final area comes out to be 105.72. All right, number 4, this is going to be an important one to know how to do. So we're going to do the area of the rectangle minus the area of the triangle. So I'm going to start with the area of our rectangle. Our area of a rectangle is just going to be our base times our height. So 2x plus 3 times x minus 4. So I'm going to use the FOIL method. So first 2 is going to be 2x squared. Outside 2 is going to be minus 8x. Inside plus 3x. And the last 2 is minus 12. So from there we have two like terms. So we're going to get 2x squared minus 5x minus 12. And that is the area of our rectangle. Then what we're going to do is we are going to find the area of our triangle. So triangle is 1/2 base times height. Luckily we already have that, so we have 1/2 4 times 7, which is going to give us 14. So from there we're just going to subtract our rectangle and our triangle. So we're going to get 2x squared minus 5x minus 12 minus our triangle, which is 14. Then again, we just have these two like terms. So our final area for number 4 is going to be 2x squared minus 5x minus 26. And that is our final answer in terms of x. All right, number 5. The area of a rectangular piece of land is 338 square miles. The length is twice the width, so 2 times the width. Find the length of the land. So our length is twice the width, and our width is just our width. So what we're going to do is base times height. So 2w times w equals 338. W times w is going to give us a w squared. On this one you can factor, but you actually don't have to. The easier way to solve this one is we're going to take both sides and divide by 2. And we're going to get w squared equals 169. And then our next step is to take the square root of 169. So w is 13. Then the actual question is asking us to find the length of the land. So the length of the land is 2 times 13. So 26 is actually our final answer. All right, number 6. Number 6 says one side of a square is 2x minus 7. Find the area in terms of x. So since it's a square, all sides are going to be 2x minus 7, meaning we're going to multiply these two together. I'm actually going to do this one using the box method just to do a different way. So we're going to have 2x minus 7 and 2x minus 7. So what we're going to do in the boxes is we're going to multiply them where they meet. So we're going to have 2x and 2x meet, giving us a 4x squared. Negative 7 times 2x is negative 14x. Then that same bottom left box, we're going to have 2x times negative 7, which is negative 14x. Then negative 7 times negative 7, which gives us 49. From there, we do have a set of like terms. So we're going to take 4x squared, subtract 28x plus 49. And that is your final answer in terms of x. All right, station 2. We're going to be using a lot of trig in this one. So, oh, just kidding. No, we're not. We don't have to. We can use our special right triangles. So, on this one, since this is our 30-degree angle, that means that this side is our x. We have our right angle, so this is our 2x. And this is our x root 3. So, since 8 is 2x, this x side is actually 4. So, the area of our parallelogram is going to be base times height. So, our base is 12 and our height is 4. So, the area of this parallelogram is 48. All right, number 2. We're going to work number 2 the same way, except now this is a 60-degree angle. So this bottom side is our x, this side is our x root 3, and that side is our 2x. So this bottom distance has a length of 4. So x root 3 is going to be 4 root 3. So using this as a trapezoid, we're going to subtract that 4 from 15. So the base up top is going to be 11. So we're going to get 1/2 height times base 1 plus base 2. So 1/2, our height is 4 root 3. Base 1 is 15. Base 2 is 11. So then when we go ahead and multiply all of that out, our total area comes to be 90.07. All right, number 3. So we have a 45-degree angle. This is not really drawn to scale, so don't go based on the picture. So since we have a 45 triangle, this is our x root 2 side. So this is x and this is x, meaning the height of our trapezoid is 8. And then these two parts are also both 8. Our middle part is also 8. So that means we're going to have, again, 1/2 height times base 1 plus base 2. Our height is 8. Our base 1 is 24. And our base 2 is 8. Lots of 8s in this one. So our area comes out to be 128. Okay. All right, so on this one, number 4, we know that consecutive angles add up to 180. So that means this angle here is 45 and this angle here is 45. So since we have a 45, 45, 90 triangle, this side is our x root 2. So the height here is 7. So then we just have a typical parallelogram. So the area is base times height. So we have 16 times 7, and our area is 112. All right, number 5, trapezoid with an area of 176 has a base of 17 meters and a height of 8. What is the length of the other base? So we have our formula. Our area is 176. We have 1/2. Our height is 8. Base 1 is 17, and our other base is unknown. So the way that I did it is I said 1/2 of 8 is 4 times 17 plus x. Then I distributed the 4. So you're going to get 68 plus 4x. You're going to subtract 68 from both sides. You're going to get 4x equals 108. Divide by 4, divide by 4, and x equals 27. So that is your other base, 27. All right, number 6. The area of a trapezoid is 80. The bases have lengths of 26 and 14, so find the height. So again, we have that same formula that we used in the top one, so I'm not going to write it down again. I'm just going to fill in what we have. Our area is 1/2 of our height, and our two bases are 26 and 14. So 80 equals 1/2 times height. 26 plus 14 is 40. Okay. From there, I said 1/2 of 40 is 20. And then divide both sides by 20. Our height is 4. All right, on to the next one, rhombuses and kites. In a rhombus, we know that our diagonals bisect each other. So this one has a length of 15 and this one has a length of 20. So we're going to have our area equals 1/2 diagonal 1 times diagonal 2. Diagonal 1, we're going to have the whole length, so that's 30 times our second diagonal, which is 40. So if you calculate that, 1/2 of 30 times 40, it's going to give us 600. Moving on to number 2. Number 2, we had it broke down. So we have 6. We're going to have this is our second diagonal. So these two parts are actually going to be equal to each other. So 6 divided by 2, each of these parts are going to be 3. Then we know that the diagonals are perpendicular, so we're going to be able to do our Pythagorean theorem to figure out the length of those other diagonals. So I'm going to do this top triangle first. So we're going to have 3 squared plus, call that one a squared equals 5 squared. When you solve for a, you get 4. Then we're going to have this second one. So this triangle here, and I'll call this part b. So we're going to get 3 squared plus b squared equals 5.2 squared. Solve for b and you're going to get 4.25. So a is 4 and b is 4.25. Last thing is to calculate your area. 1/2 diagonal 1, we know that one diagonal is 6, times our second diagonal, 4 plus 4.25 is going to be 8.25. Calculate this all, and you're going to get 24.75. All right, moving on. Number three. Number three, we're going to have to use our Pythagorean theorem again. So we're going to have some right angles. We know that this part is 12. So we can do this bottom triangle here. Oh, no, I'm sorry. We don't need that one. Do the top triangle. We need to know this length. So we're going to get 12 squared plus a squared equals 15 squared. If you calculate that all out, you're going to get a equals 9. So the length there is 9. So diagonal 1 is going to be 24, and diagonal 2 is going to be 5 plus 9, which is 14. So our area is going to be 1/2 of 24 times 14, which is going to give us 168. All right, moving on to number 4. Again, we're going to have perpendicular diagonals. This part is equal. Here's our x. Going to be doing our Pythagorean theorem again. So 6 squared plus x squared equals 10 squared. Calculate that. X equals 8. So we have 8 and 8. So diagonal 1 is going to be 6 plus 6, which is 12. Diagonal 2 is 8 plus 8, which is 16. So our area is going to be 1/2 of, 12 times 16. So our area comes out to be 96. All right, graph the following points. Find the area of the figure. So we have 4, 1, -1, 4, -2, 1, -1, -2. All right, so we have this shape, which is going to be a kite. Then the next thing we're going to do, we're going to have our diagonals. We have this diagonal here, and we have this diagonal here. So that diagonal has a length of 6, and that diagonal has a length of 6. So our kite is going to be 1/2 diagonal 1 times diagonal 2. So 1/2 of 6 times 6. That's going to give us a total area of 18. All right, number 2, find the area of the kite. So same exact thing. We have this diagonal here, and then we have this diagonal here. So this one has a length of 8. And that one has a length of 8. So again, 1/2 diagonal 1 times diagonal 2. So 1/2 of 8 times 8. So we're going to have an area of 32.